So, like I was saying the other day, we're looking at circles. Right now we're focusing on degrees, either degree of an angle or degree of an arc. So yesterday we looked at central angles. Those were the super easy ones. Whatever the angle is, the arc's the center. The next three are going to be vertex on the circle, which is what I'm doing today, vertex in the circle but not in the center, and vertex out of the circle. So basically the vertex keeps moving. And because the vertex keeps moving, the formula keeps moving. The formula keeps changing. Now, this one actually has a specific name. Kind of like central angle is a specific name. This one is inscribed. I prefer red. Inscribed angles. So inscribed angles. An angle that the vertex is on the circle. An angle that the vertex is on the circle. That's an inscribed angle. Now, same as yesterday, we're going to draw a circle. So do the best you can. Doesn't have to be perfect. Just try to make it look like a circle. And that's pretty good. You don't need to put the center in this time because we don't need a center. And I'm going to draw an angle. I'm going to start on one side of the circle. Doesn't matter where you start. Send a segment to somewhere on the other side. And then come back out. A little too far. And it doesn't matter how big it is. I mean, you could have came back out here, back out there. Doesn't matter. So that's an inscribed angle. Now, because here's my angle, and it's opening up to this arc, so it's having to actually travel further than the central one did. Whatever this is actually twice as big. So my formula for this one is going to be 2 times the angle equals the arc. So if this is 10, 2 times 10, this is 20. If this is 50, 2 times 50, this is 100. If this is 150, 2 times 150 is 300. I can also go the other way. Arc divided by 2 equals angle. So if I give you that this is 80, I can go back to the angle by dividing by 2 and I get 40. If this is 18, this would be 9. So that's the setup. Still not a hard setup on this one. Because all I'm doing is either doubling to go out or cutting in half to get back in. Are we okay on the top? Does anybody need more time on the top? So 1 and 2 are pretty easy. I'm going to still write the formula at least on these two. So I have an arc. I'm trying to get to an angle. And from what I said, arc divide by 2 equals angle. Now, I'm not going to write this for every single problem. The arc is 90. Divide by 2. The angle, therefore, is going to be 45. So I get 45. So if I give you the arc, you're going to shoot back inside. Make sure you divide by 2. Oh, I never did it. Number 2, I'm just going the other way. So this one, remember I said 2 times the angle equals the arc. Well, I know the angle is 37. 2 times 37, I get 74. So if I give you the angle you're going to shoot out, I got to double it to get to the arc. So 74. So those two didn't take any extra steps at all. No extra step on those two. But some of the other ones do take some extra steps. Are we okay on 1 and 2? 3 and 4. 3 is still pretty easy, and then 4 changes. Let me slide over a little bit. So 3, same thing as what we did before. I know an angle, I got to get to an arc. What do I do to go from angle to arc? Say it again. Multiply by 2. I get 122. That's it on that one. Now, number 4 looks completely different. And it's actually technically an inscribed angle. But because the vertex is still on the circle, it's still on. I'm still going to use the exact same formula. But I've got kind of an angle and an arc here. I have an angle and an arc kind of here. And if you notice, I've got a question mark here, but I give you this arc. I need this arc to get to this angle. So first I got to go from here to find there. Which is kind of what we did on some of the ones yesterday. So if I know the one arc is 254, what can I do to find the other arc? From? Right. All the way around this thing is 360. So from here to here is 254. 360 subtract 254. I get 106. So now this guy's 106. So now my arc and my angle line up. They're on the same side. So now I know this arc. Now I can shoot back into the angle. How do I go from arc to angle? Divide by 2. So I'm going to cut it in half. I get 53. So it took a little bit more work. Plus it just kind of looked different than the rest. But I'm still using the same formula because the vertex is on the circle. That's what you look for, is where that vertex is. It tells you what formula to use. Any questions 3 and 4? Moving to 5 and 6. So 5 and 6, still two that have kind of that different look. Again, I've got this angle, but I need this arc. Now I'm going to show you can actually do this 2 different ways. Because you can either go from this angle to this angle, then shoot out. Or you can shoot out to this arc and go around. You're going to get the same thing. You can go either direction. So first, let's try it this way. If this angle is 47, what am I going to do to find the angle next door? What do I know about these 2 angles next door? So 180, because I got a linear pair. 180, subtract 47, 133. So this guy's 133. Linear pair, blast from the past. These 2 angles have to add up to 180. Now I'm going to shoot out to the arc. What do I do to go from angle to arc? Multiply by 2. So I'm going to double it. Well, when I double it, I get 266. So that's one way you could have done it. Now I'm going to show you the other way you could have done it, because you could have gone the other direction. This is 47. So therefore, this arc that's kind of tucked into here, I could have gotten by doubling angle to arc. I would have gotten 94. Well, now if this is 94, I can subtract from 360 to get the rest of that side. 360 subtract 94. I still get 266. I just went the other way around. So on the ones that look like this, it doesn't matter what direction you hit. You just got to make sure you get the angle and the arc lined up on the same side. Now 6, I don't even have to worry about that because the angle and the arc is the same side. They didn't change sides on this one. So I got my arc. Angle is just right there. So I didn't change sides. So what do I do to go from angle to arc? Sorry, wrong way. Arc to angle? Just divide by 2. So cut it in half, and I get 64. So that was 5 and 6. Any questions 5 and 6? Oop, too far. 7, 8. Now let's make it bigger. Number 7. And we're doing a couple equations. I'm going to write my formula again. We know the formula. I always like the 2 times 1 best. I mean, you can use either one, but I like multiplying better. So 2 times the angle equals the arc. That was kind of the base formula I gave. So 2 times the angle. Do I know an angle? 50. So I can stick a 50 in there. Equals the arc. Do I have something to represent the arc? 17x minus 2. Well, now I just got to solve this thing. Go ahead and multiply this side. So 2 times 50 is 100.
It's 17x.
17x. I want to solve for the x, and first I'm going to add the 2, because minus 2, add 2. So add 2 to both sides. 102 equals 17x. Divide by 17, I get 6. So my final answer is x equals 6. So kind of the same thing as what we've been doing, just a little bit more work because there was an equation turned on. Are we okay on 7? And number 8. Now, number 8 takes more work. So number 8. Notice, I gave you this arc, but I gave you this angle. So they're not on the same side. The arc's on one side, the angle's on the other. So first I want to get to this side. So I got to get everything lined up first. So this arc is 250. How do I find this arc again? So 360 minus 250 is 110. So I get a 110 there. Now I can do what I did just a little bit ago. Because I know 2 times the angle equals the arc. Well, what's the angle? My angle's here, 56x minus 1. Equals the arc, which was 110. Now, this is one way you could have done it. I'll show another way you could have done it here in just a second. Most of the time, if you guys see a question like this, you distribute, which works. I mean, you can also divide by 2 to get the 2 out of there, but you guys usually distribute. So 112x minus 2 equals 110. Add the 2. 112x equals 112. So x must be 1. So that's my answer. Now you could have also, if this is 110, just saw that, okay, if the arc is 110, the angle would be 55, because I cut it in half. And then just said this equal to 55. It would have given you the exact same answer. It was just another way to do it. Questions? Now, let me kind of shrink this down, kind of float through real quick. The rest of this is what you're going to work on. You have about 17, 18 minutes for 10 questions. You should definitely be able to get done with 10 questions in 18 minutes. And 9 and 10 should go super quick. You're just going one direction to another. 11 and 12, you're also just going one direction to another. You're not changing sides. So it's just all right here, all right here. 13, 14 are really easy also. Just be careful which character you're going. 15 starts the ones that are going to take a little bit more effort because my arc is here, my angle is here. So you got to change sides. So be careful on 15. Same as 16. 16, my angle's here, my arc's here. So you're changing sides. It takes more steps. And then the last two, 17 is just like the first equation I gave you before. 18 is pretty close to the one I gave you before also. I gave you this angle. You kind of need to get this angle here and then go back out. You could also go here and then go that way, but I would probably get the angle and then go out. It's a little easier. If you get done, show it to me, and I will mark it. I will mark it. And something I will mention, which goes different than what I said earlier. I'm going to go ahead and stop this.